So now that we have identified the processes that are most suitable for automation, it's time to design our robots. Now what we want to identify are obviously whether or not this will be an unattended or an attended robot, what type of intelligence the robot should have, the data and the interaction that the robot should display, and the process that we're trying to follow. Now the approach you want to take when designing your robot is that you take the process that was identified in the previous step and then you start detailing it out. So basically what that means is that each trigger, decision, and action that is taken within a process should be assessed for feasibility for automation. So we took the processes from the discovery phase and we want to make sure that we add more detail and see whether or not it's feasible to automate a specific step. So, with regards to triggers, we need to identify whether or not the trigger is a human that initiates the start of the robot process or that it is some electronic way of activating the process. This is a very detailed step that needs to be identified in detail. Later in this learning path, we will have a lot of opportunity to look at the different steps in the process and the different assessment criteria we have for making sure that it is suitable for automation. But one of the things you want to be absolutely clear about is what the triggers for the process are and what the triggers for ending the process are. So with regards to decision moments in the process, we have to look at the data, but also whether or not it requires physical input or digital input and what the business rules are for actually making that decision. So is there objective criteria for making decisions on this process, or is it subjective criteria? Objective criteria usually meaning business rules that exist within applications, and subjective criteria are usually decisions made by humans in the process. This is very important because it's hard to automate subjective decisions in a process. Then we need to look at the data sources that provide us with the input needed to make the decisions. We have to look at who has decision-making authority. So if there's actually legislation that determines that a human should make the decision, and we need to clearly identify the decision-making criteria. So that means the business rules that are associated with making the decision. The decision moments in a process are usually the hardest to automate. And then there are the actions that need to be automated. Now obviously, if there is a physical component to the actions, it's hard to apply a software robot. But the suitability of software robots or human interaction is also important to be determined. So we definitely want to look at the data that is used to make the action and whether or not it needs to be manipulated. We want the actual action to be performed to be explained in detail and see whether or not a software robot can actually handle this action. We want the desired outcome of the action, so the updating of a file or again the data that is manipulated. And we want deviations to the action. So what happens if something cannot be manipulated and what happens if the unhappy flow needs to be initiated within the process. So the actions in the process that need to take place also need to be defined and we can determine whether or not a robot is most suitable to do so. Now with regards to tooling to designing your robot, each RPA vendor will have their specific tooling to design your robot. However, most RPA vendors will provide you with the opportunity to go from process modeling to actually data rules to implementing the robot. So they will have tooling in which we can use process models and then put another layer on top of that process model to see whether or not it is suitable for robot automation. After that, it's usually a simple step to actually develop your robot based on the input of the process model and the business rules we initiated there. So in the next clip, let's take a look at how we can best develop and test robots using the software that is provided by most RPA vendors. So after we have designed our robots, it's time to develop and test them. Now this is obviously where vendor-specific software comes into play. Now it's important to realize the difference between top-down robot development and grassroots robot development. Where we have the center of excellence within an organization that does top-down development of robots, usually they create these big RPA robots that look at significant processes within the organization that are suitable for automation, and it takes a long time to develop these robots with a lot of testing involved. However, when we look at the grassroots approach, there are usually smaller robots and they require less technical know-how. So, bot development tooling usually comes in two forms. One is a sophisticated, technically driven application that allows for sophisticated robots to be created. However, on the grassroots level, we have a what you see is what you get type of approach with low or no code platforms that allow business users without technical know-how to create robots for themselves. This is where the automation on the desktop usually happens. Now, bot development tooling that is technically driven is used for the most sophisticated robots, while the what you see is what you get or low code or no code platforms are better suited for small robots that help with specific parts of specific processes. Now, with regards to test tooling, most of the vendor software out there that has test tooling embedded in it is very technically sophisticated. But the testing that goes on the grassroots level usually consists of users checking each other and see whether or not the robots work. So we see on the grassroots level, there's usually a more user-driven approach to testing because the processes are less sophisticated and there's a lot less errors in these processes, while the big robots that are created by the Center of Excellence usually involve different test cycles and specific test tooling that exists within a development suite of the vendor. Now, as organizations start to develop more robots, it's quite possible that one of the robots that is created on the grassroots level, that after we do some metrics on the robot, it seems to be a very effective robot that has a very high return on investment. If this happens, typically we see the robot being taken into the maintenance concept of the Center of Excellence, and they start developing more sophisticated tests and development cycles on this robot in order to best exploit it and perhaps even distribute this specific robot to multiple users within the organization. This is where a grassroots robot becomes a top-down robot and it's part of the integration phase of an implementation. But we will talk about the way that organizations implement RPA in the next module. It's important to realize though that it's quite possible for robots that exist on the grassroots level to eventually be distributed within the entire organization. Now, with regards to the approach to development, we definitely advise to take a more agile approach. So instead of letting the Center of Excellence operate as a specific project, it's important to involve the users of the process within the development cycle of the robot. So we make a dedicated team that exists between the technical people of the Center of Excellence, but also the business users that will be using the robot in order to take the most agile approach. That's why it's so important to realize is that the robot lifecycle usually exists of multiple cycles where we develop and test and deploy a specific robot multiple times and make incremental improvements so that it becomes more effective over time. But more on the approach of developing robots later in this learning path. For now, it's important to realize that close collaboration between the Center of Excellence and the users of the robots is vital for effective development and testing of the robots. Now, of course, after testing, it's also important to deploy and maintain the robot over time. This is where we reduce the total cost of ownership of robots. So let's take a look at that next. After robot development and testing, obviously we want to deploy the robots. Now, there are not a lot of flavors with regards to deployment of robots. We either deploy the robots in the cloud or we deploy the robots on premises with software that is provided by the specific RPA vendor for implementation on the infrastructure that exists within the organization. Now, we will go into the details of deployment of RPA robots and the technology behind it later in this learning path. It's important to realize that with regards to deployment, on-premises brings with it more sophistication and probably more dedicated tooling. However, a cloud-driven approach definitely makes for easier management of the robots within your organization. The important part, however, is not the deployment of robots, which is basically just another layer of software that exists within the organization. It is the maintenance of robots. One of the main pitfalls that exist with most RPA implementations is when we reach a certain number of robots in the organization, it becomes very difficult to maintain those robots because they operate on an individual level, and it's hard to scale up the number of robots in order to most effectively automate away the repetitive tasks in the organization. Most RPA vendors will provide you with an orchestrator that specifically looks at maintaining the robots and distributing them within the organization. So what an orchestrator does, it looks at the health of the different individual robots that exist within the organization. It monitors the connection between the robot and the applications in the organization, and it looks at the applications themselves and whether or not they are running effectively. It does this by plugging in directly with the robots, but also the APIs that exist within the different applications in the organization. So an orchestrator is basically your monitoring tool that exists within the Center of Excellence that monitors all the robots that exist within the organization and looks at their health status and whether or not they are still effective. An orchestrator is vital to scaling up RPA within your organization. Now, of course, next to managing the robots, you also want to make sure that you measure their effectiveness. So let's take a look at how you can do that within large organizations.